So we have something called a standard normal distribution now that comes to our discussion, where any normal distribution. So let's understand what a standard normal distribution is. It has a mean of 0 and standard deviation of 1. You can convert any normal distribution to a standard normal distribution by finding the z values. So when you take a normal distribution, you can find z values for each of the instances, and that automatically converts it to a standard normal distribution. Let's take an example. Consider a normal distribution with a mean of 5 and standard deviation of 2. So effectively what we are talking about is this distribution. Let's say this is the distribution. The mean is 5. Then you have 7 here and 3 here because we have sigma as 2, 9 and 1, and so on and so forth. If I find the z values of all these terms, so let's solve for z. The mean is 5, so mu gives me 5. If I solve for the z value corresponding to this is 5 minus 5 divided by sigma, which is 2, that will give me 0. So I can create a new curve now, which is the z curve, where corresponding to this 5, I have 0. Let's assume 3 standard deviations away, we have 11. If we want to solve for this value, 11 minus 5 by 2 will give me 3 effectively. 6 by 2 will give me 3, which means corresponding to this 11 here, I have 3. If you solve for the others, you will have effectively converted this first normal curve, this one, into a standard normal curve by using z values. Fine. Now what does z value mean? Z effectively is the number of standard deviations away from the mean. So effectively, when I say z value is 2, it means it is 2 standard deviations away from the mean. If I calculate z value for this 11, which we calculated it to be 3 here, this means this number 11 is 3 standard deviations away from the mean, which is 5. That's what z value tells you. When you look at the z table, the value that you get is the probability of having returns lesser than that z value, which is the area under this part of the curve on the left side of this line. That is what the z values tell you. So that's what we will look at and go ahead very quickly. Now the z value, when looked up in the table, gives the probability that a variable is less than that value in terms of, this standard deviation numbers. This is the probability of the value being on the left of a given x. The probability of the value being to the right of x is given by 1 minus pz is less than equal to x, which is just what we found out. If z value is negative, probability of n minus x is equal to 1 minus nx. It's a symmetrical curve, remember. So if the z value is negative, you just need to subtract that from 1 to find the probability on the other side. Let's solve a question around this very quickly once again. So when we look at z values, we have a question here which talks about, let me delete this bit. Let's understand this. It says a stock's returns are normally distributed with a mean of 15% and standard deviation of 27%. I want to find the probability of returns being less than 20%. Fine. So here, effectively, the normal distribution says the mean is 15%. The standard deviation is 27%. Another 27%, right? So it goes till 42%. 42% effectively is mean plus 1 standard deviation, correct? Now, the probability of returns being less than 20%, I need to find out 20% here. So effectively, let's draw this again so that it is clearer. If we are drawing this again, effectively what we see is this. This is 15%. The probability of returns being less than 20% is effectively this part of the curve. So if I can find the z value of this 20%, the number under the z table should directly give me that probability. Fine. How do I solve for z for 20? X minus mu by sigma, which is equal to 20% x. minus 15%, which is mu, divided by 27%. Solving for that, this is the numerator, 5%. Solving for this, we get 0.185. Now, if we go to the Z table and search for 0.185, we will find the probability there. So let's look at the Z table. Here is the Z table. We have to look at 0.185. Fine. So let's look at that. Let me just increase the font a little bit. How do we spot in the Z table? This is 0.1 and 0.1112 all the way up to 0.18. So roughly around 57.14 or 57.4% is the probability of returns being less than 5%. 57.14. If I take it as 0.18, 0.185 will be the actual interpolation between these two terms, which is roughly 57.3% is what we will take as the probability. So we go here, that's what we get. 57% is the probability that we get. Fine. Now let's look at the second point, which is the probability of returns being between 15% and 25%. Remember, 15% is the mean. So the probability of returns being below 15% is 50%. If we can find the probability of returns being less than 25%, then all we are trying to solve is, if let's say this is 25%, then all we are trying to solve is this part of the curve. The green part of the curve is what we are trying to solve effectively. So let's find the 25% corresponding Z value and solve for that. So what we see here is the Z value corresponding to X equal to 25%, which is 25% minus 15% divided by 27%. I get this value. Let's find the probability of returns being less than 25%. That's 0.37 in the Z table. So Z table 0.37, 64.4% is the probability of returns being less than 25% in this case. So 64.4% is the probability of returns being less than 25%. What is the probability of returns being less than 15%? Less than 15% is 50%. We are effectively looking at calculating this area, which is nothing but 64% minus 50%. That gives me the answer. So the probability of returns being less than 15%, probability of, so let's write that down, less than 15% is equal to 50%. The moment you solve for this, between 15 and 25% is equal to this 64 minus this 50, which is 14.4%. Fine. That's how you will solve for Z. Note that what we are finding as Z values is effectively the number of standard deviations away from the mean the value is. So this value, 25%, is 0.37 standard deviations away from the mean. The value 20% is 0.185 standard deviations away from the mean. Fine. That's how you would look at calculating this.